Well, our closing talk of the day is on a topic that we know is very near and dear to many of you. And that is the topic, the very evolving and dynamic topic and debate around observability in engineering and how to approach it. It's my pleasure to introduce Charity Majors, who is CTO, ops engineer, and co-founder of HoneyComb, a modern observability platform. Prior to HoneyComb, Charity worked at Parse and Facebook on operations and dev tools, and always seemed to wind up, quote, running the databases, unquote. She co-authored O'Reilly's Database Reliability Engineering, and I am also told that Charity loves free speech, free software, and single malt scotch. So you've come to the right place. I don't know if you heard about our whiskey tasting, but this is a good spot. Charity, thank you so much. Take it away.
Let's see. Am I on? Sounds like I'm on. Excellent. Well, I had planned on being here all day, but my day became a bit dramatic. One of these days, I'm going to have to learn how to use PowerPoint. So that was the first half of the day. And then I just got in a tiny little car accident. So adrenaline is pumping. At least I'm here for the end of the whiskey, right? That definitely wasn't the plan all along. All right. So I'm going to be talking about, and by the way, thank you for whoever took charge of making my slides finally format. I spent so many hours on that, and I couldn't get it to work, so thank you. The paradox of alerts, why deleting most of your alerts can actually make your systems better, and how to build an on-call rotation that engineers are happy to join. They might even volunteer. My name is Charity. That was a great intro. Thank you so much. I work at HoneyComb, and not only database reliability engineering, I need to update my bio, but observability engineering, the book that I just co-authored with Liz Fong-Jones and George Miranda, was just released. People have been getting their books this week. So, it took us... In true engineering fashion, we scoped this to take us about 9 months. It took about 3 years. So, you know, but it's done. Bloop, bloop, bloop. All right. For those of you, how many of you have been engineers or are engineers at some point past present life? How many of you who are engineers have never been in an on-call rotation? Oh, beautiful. We're among friends. All right. Well, how many of you ever found yourself thinking or saying or hearing things like this? My time is too valuable. You don't want me firefighting. Or it gets sadder and sadder. Maybe this will keep people out of engineering. Or if you're more on the manager track, maybe it looks something like this. Sometimes you just have to sacrifice your engineers at the stake. It just has to be done. Or, I did it. Now it's your turn. This is my favorite. You aren't a real engineer until you've done this at 3 a.m. Well, there are a lot of regrettable patterns out there when it comes to being on call. But it genuinely doesn't have to be this way. We can actually do a lot better. And I am here to convince you of this. I believe that an on-call rotation can be sustained by mature adults with families, children, and lives who go backpacking. And I also believe that it can be something that is somewhat aspirational. I think it can be a role that people can be proud that they can aspire to want to hold. I think it can be something that they look forward to. And I also think that as management, it's one of the sharpest tools in your toolbox when it comes to creating alignment and when it comes to motivating people and when it comes to all being on the same page. There's just a lot of good stuff here. On-call is a lot of things. It's a critical part of owning your code. It's a social contract. It's an expertise of there's a deep well of expertise in doing on-call well. It's a pretty good proxy metric for how well your team is performing, how functional your system is, how happy your users are. And it's often a miserable, torturous hazing ritual that's inflicted on anybody who doesn't have the power to opt out. I think if software is a socio-technical system, right? And it has two really big, powerful feedback loops. And if you want to have a really high-performing team, or if you're trying to lead engineering, these are the two to think about and really study. One of them is software ownership. The other is deploys, the process from when you merge your code to main or master, you run your tests, and you get it deployed to users. I talk a lot about the second one. Today I'm going to talk about the first one. Software ownership is, right, levers, GIF, great. Software ownership is when you basically put engineers on call for their own code in production. Now, that's not all of it, of course, but it is a really critical, it's how you close that feedback loop, right? And I think of this as the original sin of dev and ops, is when we spun them out from each other and we made them two separate things. That was a terrible idea. I get why we did it. We're ooh, specialization, this is a thing, we should specialize. And, we went down that road for a while, we realized it was terrible, and now we've spent the past 15 years trying to backpedal. It was always a bad idea to have different people run the code than write the code. And the more complex our systems get, the more this error becomes evident. As the complexity of our systems is just off the charts for all the reasons on the left and more, the ability of anyone to debug and fix and run these systems who didn't write and doesn't own those systems is coming to an end. Who should be on call for their code? It used to be ops teams. I would say now it's any engineer with code in production. Is this payback? As an ops engineer, definitely not. Of course not. Why would you ever ask such a thing? Yes, okay, ops has always had a thick streak of masochism. We've always prided ourselves on, missing the most sleep and terrible things in our 20s. Once we get to our 30s, we don't want to get woken up either. But this genuinely isn't about making software engineers as miserable as we used to be. It's about, this is actually the only way that we can make things better. Nobody should have to be that miserable. It is technically, it is actually very possible to have an unhealthy system with an easy on-call rotation. All you have to do is ignore most of your errors. It's also very easy to have a healthy system with a terrible on-call rotation. These things they don't necessarily go together. There's some connection, but it's not necessarily a tight one. What is true, though, is that you really want to make sure that your engineer's pain is closely aligned with your user's pain. That's step one. Step two is you track that pain and you kill it. Pay it down. Sorry. I also think of on-call responsibility as being a social contract between engineers and managers. Engineers, our job is to own our code. We wrote it, we built it, we made it, we own it, right? We have responsibility for it. Managers, your job is to make sure this doesn't suck. And I started talking about this, I don't know, a couple years ago, and then I started getting this back-channel feedback. Engineers would come to me and be like, my manager says that engineers are supposed to be on call for their code. I hate you. And I'm like, well, that's not the whole story, right? Yes, you should own your code, but if you're at a place where you're getting woken up every night, or it's abuse that you can't sleep, you should quit. Don't work there. This is a handshake. We both have to do our parts. And management's job to make sure that on-call doesn't suck is very serious. It's a responsibility that I think that most of us don't take nearly seriously enough. Click. But never getting paged is not actually the goal. It's not possible, for one thing. And it's not really desirable either. These systems are incredibly complex. They degrade in fascinating, unpredictable ways. And you don't actually want the robots to run the entire show. I think of disruptions, I think of engineers as being a lot like doctors. Being on call is it's part of the gig. You sign up for it, right? It's actually way more stressful to get paged or alerted in the middle of the night or whenever for something that is that you don't understand, or that's new to you, or that doesn't make sense, or that you're getting conflicting information. That's way worse than getting an alert about something that you're I know how to deal with this, right? Oh, I know where to start. I know. Okay, if it's something where oh, this is obvious, then probably should automate it out of existence. But like if it's like, oh, okay, I know where to start, I'm familiar with this, I know how to use my instrumentation, right? That's not scary. Our target should not be tracking things that we, that we hope will never happen. It should be tracking things that we know will improve our operational health and make people's lives better. There's a great blog post by one of the honeycombers, Fred Hebert, very recent one. I recommend it. He talks about this a lot more. But I personally believe that any engineer who works on a highly available 24/7, 365-day-a-year highly available service should be willing to get woken up a couple times a year for their code. I think that's just baseline. And this is not really unrealistic. If you're on an 8-person on-call rotation, that's 1 week out of every 2 months. If you get woken up once every other on-call shift, that's 3 times a year. It's once every 4 months, right? That's not bad. This is very achievable for just about everyone. If you can write a test suite that you more or less trust, you can achieve this. It's not even that hard. It's just engineering. How rare is it that we can just say that? It's just engineering. It doesn't actually take, it's not particularly difficult, it's not particularly challenging, but it takes consistent application of engineering principles and attention and just paying it down, putting in the time, doing the work. That's all. Many objections that I've heard to this. My time is too valuable. I don't know how to use production. I have a new baby. All right, that one I'll give you. Whose time is it? This is where this really gets my goat as an operations engineer, right? There's a not so subtle classism in this that states that software engineers' time and sleep is way more precious than anyone else's. Look, if you're not getting woken up to own your own fucking code, someone else is getting woken up for it. And they're just gonna take them longer and it's gonna be way more wasteful. Like, just own up. If you don't know how to navigate production, this is your great opportunity. I firmly believe you can't really be a successful senior software engineer unless you understand how to operate your code in production. Unless you understand what happens after you hit deploy, unless you understand how it fails, and unless you can deal with it, right? Anyone who spends all their time in their IDE is not a senior software engineer. They're just like solving puzzles. They're not dealing with the reality, the conjunction of code and infrastructure and production and right now. If you have a new baby, fair. Nobody should have to deal with 2 things waking you up in the middle of the night. I'll absolutely grant you that. If you have a follow sun rotation, awesome. This makes things really easy, but it doesn't absolve you of ownership. Actually, if you have a follow the sun rotation, I've seen it very often break this connective tissue of the software ownership feedback loop, and software devolves. It gets worse. If you're not closing that loop, if you're not experiencing the consequences of code that you have personally unleashed in this world, it's not okay. If you need your sleep, we all do. And if you just don't want to, there are lots of other kinds of software in the world, and I suggest that you go pick one. Seriously, there are lots of kinds of code that you can write in the world that do not require it to be available 100% of the time. And this is a pretty bright line for me at this point in my career. So let's make on-call fun again. How do we do this? First, we align the engineering pain with user pain by adopting, some best practices. Then we track that pain, we pay it down, thereby making your systems way more resilient and successful and happy. 3, profit, I assume. So, oh, and if you like these stickers, I think we have a bunch of them upstairs. All right, where are they, Rick?
They're up on the Slack page.
Rad, thanks. This one says, that which does not kill us makes us fragile and full of one-offs. Okay, the first and possibly most dramatic thing that you can do to make your lives better when it comes to on-call is, if you haven't yet gotten rid of all of your symptom pages and replaced them with SLOs, do that. Like, we consistently see teams get to delete like 90% of their paging alerts if they switch to SLOs. This is an absolutely necessary thing to do as you scale because, you know, you can start out doing stupid shit like, sorry, I'm patting off. You can start off by doing terrible things like, you know, paging on high CPU and like, ooh, this memory is like about to run out or whatever. And it's not that bad for that long. You're just waking yourself up unnecessarily, but you know, you can take it for a while. But there comes a point where you can't. There comes a point where stuff is just like going off constantly, and it's going to drive you nuts, and you're going to start to get numb to the act of getting paged, and you start sleeping through it, or you get like this PTSD, like knee-jerk reaction to like the sound of your ringtone, and you'll never be able to hear it again. Neither is great. You want to replace it with SLOs, which are service level objectives. You also want to give up the glorious dream of predictive alerting. Everybody's like, oh, I believe that if I alert on this, that I can catch it right before our users are affected. No, you can't. You can't. Alert as soon as your users are in pain. That's it. Your code should fail hard and fast. Your architecture should provide partial graceful degradation. We have a sticker for that, too. If you liked it, you should put an SLO in it. We also have T-shirts for that. And that. So SLOs are basically, you know, they came out of the budget of the Google SRE book and very googly stuff. But it's basically just setting a budget for yourself. It's like, you know, okay, we say for our business, you know, okay, so we have like an API endpoint and we have like the UI endpoint. So when it comes to ingesting our customers' data, you know, it's super important that, you know, we move it out of our customers' RAM and onto S3 like as quickly as possible and drop like almost none of it. So we're like, okay, so like, you know, 99.9% of all writes need to be stored within, you know, I think it's like 10 seconds. I think an alarm literally goes off if it's like less than 10 seconds before we get the data written to disk. But for the UI, you know, we can handle some more errors because clients will just retry, you know, people will refresh, like it's fine. So our SLO for that will be like, you know, we want 99.5% of all web requests to succeed within 3 seconds, right? And then, I should have put a graphic up here of like the HoneyComb SLOs, which I will say is the best SLO product in the world. Not because I made it, but because Liz Fong Jones came and made it, and it's just beautiful because you can see like how quickly you're spending your budget, right? How long is it going to take you to exhaust the budget? And this is the budget you have agreed with your product team and your business team and your users. This is the quality of service that you are agreeing to give them. So it's pretty important, right? It's also a lot better for you to be like, you know, having a 0.2% error rate that's like spending that budget down a little bit more quickly than you would like it to, so you can wake up in the morning and deal with it instead of having to page yourself at 3 a.m. and deal with it, right? So if you can shift your entire like paging, alerting like ideology away from, you know, nodes and disks and instances and processes, like screw all of that and go to budgets, it's life-changing. It's absolutely life-changing. Flappy alerts are worse than actual outages. They will burn people out. They will make people angry. They will make people just like stop checking or paying attention to their page. Like all of these are bad. Kill them. So if you're moving to SLOs, you might be like, well, a lot of things are going to break, right, that are not contained within your very few SLO budgets and maybe a few end-to-end checks, and you're right. This is why you should always have 2 and exactly 2 lanes or channels, right? There's the wake me up at all hours of the day and night lane, where you have like a small number of things you carefully curate and tweak and, you know, blah, 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 but they're like day or night, you respond. And then there's like everything else, which you should aim for like a 12-hour SLA on, right? So that whoever's on call can wake up and do a pass-through in the morning, work all day on whatever they want, and then before they go home at night, do another pass-through. You know, this is like your, okay, my disk filled up, or, you know, I got processes that aren't restarting, or just the cruft that accumulates, right? You don't want to have more than 2 lanes because that just gets incomprehensible, but you want to have 2. And there's a step in here that a lot of people, oh God, I gotta speed up, sorry. A lot of people will spend like a month or two in there just spending a lot of time moving alerts from lane 1 into lane 2 by making them resilient, reliable, adding chaos experiments. A super fun thing to do is to take something that is breaking and paging you at 3 a.m., do it over and over and over and over again so that it stops being flaky, and then just like set it up to do. So what we do at HoneyComb is, we have Kafka and then we have our like home brewed database, and both of them have an elaborate boot process, right? Where they have to boot and then they have to like sync, rsync or replay off of the query log. And we kept getting woken up for these in the middle of the night. And so instead, now we kill the oldest Kafka node every Monday at 2 p.m. and the oldest retriever node every Tuesday at 2 p.m. So we're always practicing the boot process, right? So it's not flaky at all. And we just never get paged about it anymore. It's fantastic. Out of hours alerts, yeah. These are not diabetes, these are a heart attack. Every single time you get paged out of hours, you need to retro that and fix it. Should only come from one source. They should be tracked and graphed, and there should be like a starter link, right? You get paged, there's the link, start here, whatever. It is way better to have a bunch of things paging you in the daytime while you're already at work than to have one thing paging you in the middle of the night, right? So you might even want to add like the concept of daytime hours and nighttime hours. And it's better to have as infinitely number of lane 2 alerts than one 3 a.m. paging alert, right? Know what burns you out and really limit those. You've got to invest time into training people, let them shadow, blah, blah, blah. Teach everyone how to hold safe retros. Yelling at people and telling them how to be safe, though, doesn't actually work. So yeah, train them, teach them how to hold a safe retro, but then like have a list of experienced people who are holding retros, and just make sure that they go and observe in a couple. Make sure that they experience what it's like to be in a room where everyone's safe going, man, this technology blows. This is the worst, right? They need to feel how okay it is to hate their software. And when it comes to like, doing like analysis of your outages and stuff, Jelly is, I think, the best tool out there. I think Nora's here in the audience. So if you need that, see her. We use it. It's great. Human SLOs are another really fun tool. For example, like we're like, okay, nobody should have to be on call 2 bad nights in a row. So if you had a bad night, somebody takes the pager the next night. Nobody should have to feel like they need to have permission to like not come into work the next day, right? And if the rate of change exceeds the human SLOs for the team, like just pull back on the throttle a bit. Managers, I think you should never put them in the critical path, but it's very good if they stay in the technical path. And I think the ideal solution here is to have them not be in the rotation, but to pinch hit and substitute generously, like even once a week. It's great if they feel the same pain as their teams do. There's really no substitute for feeling the same pain. That should be a 2, maybe. Oh, yeah, there's a 2. Cool. Track that pain and pay it down. Invest in observability. It's not the same thing as monitoring, and you probably don't have it, although your vendor probably tells you that you do. I have ranted about this a lot, so I'm not going to do it here. There are links there that you can follow. But in order to have observability, you have to be capturing telemetry from your system, arbitrarily wide structured data blobs, 1 per request per service. You have to, and your storage engine has to handle high cardinality, high dimensionality, and have explorability instead of just like, fucking dashboards that you scroll through and like using your eyeballs to just like scan for, ooh, does that spike look at any other spikes? Like, that's not science. Most of us are a lot better at writing debuggable code than observable code right now, but in my favorite / most obnoxious summary that I think I've read yet, in a cloud-native world, observability is basically debuggability. You could even say that like cloud-native monitoring, I can't say it, it hurts too much. Cloud-native monitoring is kind of like observability. If you want to read a great blog post about this, there's links at the bottom. The one at the bottom is someone talking about observability with a precarious grasp on the topic, and it's fantastic. If you really want to get a jump in the next 10 years and evade vendor lock-in, embrace open telemetry now. It's finally to the point where this is a reasonable thing to say, and I encourage you to do it. And if you are a Datadog customer, ride their ass about the fact that they have. All right, so the thing about OTel, right, is that you're supposed to be able to instrument your code once and then try any vendor that you want, right? You're supposed to be able to go from one to the next and try them out without getting stuck and locked in. Everyone in the world is playing nice except Datadog. They've made it so you can get your data in, but you can't try any other vendors, and I'm really upset about it. Instrument your code for observability. Metrics and logs can't give you observability. Like I said, I rant about this a lot. Tests are great. I'm not saying you shouldn't write tests. You should absolutely write tests. But tests really, they end at the edge of your laptop. And all that they're really doing is telling you, yes, your code is probably doing what you think you're telling it to do, and you probably haven't had any regressions. This is not the same as gaining confidence in your code by any stretch of the imagination. You need to get your code into production as quickly as you can. Use feature flags. Practice auto-deployment. But instrument your code as you go, right? And then as soon as you've deployed, look at your code through the lens of the instrumentation that you just wrote and ask yourself, is it doing what I expect it to do? And does anything else look weird? This should be muscle memory for everyone who's writing code because, oh, man, there's what I want. Because, all right, fine, I'll go. No, can't. Ordering. The cost of finding and fixing bugs goes up exponentially, beginning with the moment that you actually write the bug, right? You type it, you backspace, good for you. You ship it out, your best chance of finding this bug is to find that bug right there, just as soon as you've shipped it, because the longer it lives, the more expensive it's going to get, and the harder it's going to be able to find. There's this magical moment where you've just written the code, you know exactly what you're trying to do, you know why you're trying to do it, you know what you tried to do, what didn't work, what did work, what the variable names are, what the function names are. Your original intent is, nobody will ever have the same original intent. You can't get it back. And then you deploy it, hopefully, and then, you switch your attention to another project, and it all just gets swapped out very fast. So it's really critical that you look at it in production before you start swapping out and swapping in something else. So this is super important, right? As your team begins to climb out of this pit of despair, you're going to get paged less and less. But in order to stay that way, you have to stop relying on firefighting and stop relying on your users to inform you when you have bugs. And you have to start getting much more proactive about it. Like I said, you need to look at your code after you shipped it, use your instrumentation, look at your instrumentation, look for outliers. This is why observability is so important with the raw rows and the ability to do max and min, and look at percentiles. Percentiles are bullshit. Even 99.99%, it's not actually gonna tell you the edge cases that you need to know about. If you have instrumentation that rewards your curiosity and that helps you understand your systems and makes it validating and fun to follow the trail of breadcrumbs to the answer, then slowly your systems will become less and less of a mystery to you. They'll become less and less of a black box. They'll become not only less noisy and less bothersome, they'll become better systems. Right now, most of us are working on systems that are like a hairball that the cat coughed up. It's code that nobody's ever understood, written, shipped. It's code that nobody understands, and they're shipping it to code that nobody's ever understood, and it just keeps growing. This is not. And then we wonder why firefighting is so awful. It's a shit show. We can do better. If it's too big to be fixed by on-call, get it on the product roadmap. Make sure your engineers get enough time to fix retro action items. The only thing more depressing than not being asked or not getting to list out and figure out what's wrong with your systems is doing that work and then not doing the work to figure out what needs to be done and then not getting the time to do the work itself. It is so demoralizing. And at the bottom, this is just kind of it. We all need to get so much better at quantifying, explaining the impact of the work that increases reliability and, improves our velocity and makes it so that, you go to write a feature and it doesn't turn into like, oh shit, now I have to touch like 50 different things. Like, this has a material impact on retention, velocity, happiness. The only thing more than this that I think you should do in order to keep your best engineers happy is 15 minutes or less, auto-deploy all your changes. As soon as you've merged your changes to master, create an artifact, run your test, create an artifact, auto-deploy it. It will change your life. Everyone will be so happy. You have no idea. I couldn't fit that into this talk, I'm sorry. This work is not secondary to features. It's just as important, maybe more important, because if you don't do this work, none of your other work matters. Also, I think that being on call really gives you the moral authority to demand that things change. It gives you the moral authority to demand that things get put on the roadmap because it's hurting you. I saw that there was a panel about this, and I'm so delighted. Test in production. This is not a question of whether or not you should test in production, because you are. Everybody is. It's a question of whether or not you admit it and try to do it well or not. Or if you're just like, ooh, I don't do that. Like, come on. Run your chaos experiments, invest in your observability. Oh, God, I'm out of time. It's like 2 or 3 more minutes, I swear. Track the things that you can do, not the things that you hope don't happen. It's not about having no incidents. It's about making people feel confident when they're on call and reacting in a helpful, useful manner. The best way to judge engineering velocity and effectiveness is not to capture a bunch of useless metrics that they will then gain because they're engineers, is to ask them. This is the survey that I am literally writing as of yesterday to survey our engineering team. And it's basically like, what percentage of your time in the past 30 days have you spent on the work you planned to do versus the work that was unplanned? What best describes the unplanned work? A task that I thought was a pebble turned out to be a boulder. I was bitten by an undocumented and undiscoverable dependency, etc. And also, it's important to keep it small, like 5 questions or less, and then ask it repeatedly, like once every 2 weeks or once a month, because the trend almost matters more than the actual absolute numbers. But I also like to ask, how often in the past quarter have you ended a project having created more technical debt than you removed? Because typically companies are either good at vertical ownership or horizontal ownership, and nobody seems to be good at both. If you think that you are, I would love to talk to you. Managers' reviews, I think, should be directly linked to how happy and effective their teams are. There are some really tricky incentives here, like you don't want to disincentivize managers from taking on tough teams. But the way that we do manager reviews now is batshit. We're just like, how well do you feel like you did, basically? It's stupid. So, profit. We're basically there. We're about there. How well does your team perform? This is not the same question as how good are you at engineering. It's a very, very, very different question. High-performing teams are the ones that get to spend most of their time on interesting, novel problems that move the business forward. Lower-performing teams, by which I mean like the bottom 90% of us, spend more time doing everything else, literally everything else. In order to be high-performing, we need to build only what we absolutely have to. Spend your engineering cycles are the scarcest resource that you have. I don't understand anybody these days that is building anything that they don't have to. Like, as much code surface as you can delegate to someone else who will do it better than you, the better. It's way easier to keep yourself from falling into a pit of doom than it is to dig your way out of one. Dedicated ops teams are going the way of the dodo bird, but operational skills are absolutely more important than ever, especially if you're dipping your toe into microservices. If you underpay or underinvest, you'll be sorry. Super important investments to make: decouple your deploys from your releases using feature flags so that you can continuously deploy while also releasing things in a sane and controlled manner. Get your run test and deploy time down to 15 minutes or less. Invest in auto deploys and progressive deployment. If you want to know literally how high performing your team is, other than the subjective survey, the DORA metrics are kind of the gold standard, right? Although I would add a 5th, which is how often do you get paid outside of work hours? It tracks really closely to people getting burnt out and feeling like their labor is not appreciated. There's a huge gap between quote-unquote elite teams and the other 75%, like 973 times more frequent code deployments. These things matter. These things matter a lot. How many of your teams are tracking these things? 1, 2, 3, 4, maybe 5. Yeah, that's about normal. It's crazy, right? We're engineers. We care about data. How are we not tracking these things? A lot of us think that the way to make great teams is like, hire all the great engineers, but it actually works in exactly the opposite direction. You can't assemble a great high-functioning team by hiring a bunch of individually productive engineers. And great engineers, like we have an apprenticeship industry, right? If you get to work on a great team, you're learning millions of collective engineering hours of learning about best practices and good defaults and like sane ways to do things. And your productivity will rise or fall to join that of the team that you join within like 3 to 6 months every time. You can't take a median, say 50 percentile performing team, add a so-called great Google engineer. You're still going to ship in exactly the same amount of time, right? Conversely, if you ship your code in 15 minutes or less, automatically every time, every engineer that you add to this team is going to ship in 15 minutes or less. This is a fundamental attribution error, right? Sociologists call it FAE, which is that we tend to think that like we're 90% of our effort is done by us and 10% is by the system. But when it comes to these socio-technical systems like software, it's the opposite. We don't pay nearly enough attention to these socio-technical systems and the feedback loops that drive them. Instead, we focus on trying to grill all of our interviewees and on their data structures and algorithms. Doesn't make any sense. Your ability to ship code swiftly and safely has a lot less to do with that, and a lot more to do with the system. So technical leadership, if we think we're worth our paychecks, should probably focus on constructing and tightening those feedback loops. This is not just for rockstar teams. Honestly, it's so much easier to write and own and ship software if you have good operational hygiene. It's so much easier than it is to like be a software engineer on a low-performing team. It's insane. The biggest obstacle that I see to teams like actually getting their shit together is generally lack of hope. They don't think that they deserve nice things. They're like, oh, that's just for the Googles and Facebooks of the world. No, it's not. It is not. This is not hard engineering. It just takes focus. It just takes paying attention to feedback loops, learning from our mistakes. Occasionally, it's really shitty management, though. It's a lot easier to work this way. And if your team can write decent tests, you can do this. So now that we've done all this, tamed our alerts, switched to SLOs, fixed our systems, instrumented, auto-deployed, blah, 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 you're like, well, I'm still not happy. You told me I was going to be happy to be on call, and I'm still not happy. You're right. I saved the best for last. The goodies are, this is part of the compact that you make, right? Managers and engineers. Your engineers agree to be on call. Your managers agree to make it not suck. If you're on call, you are not to work on the features or the roadmap or anything related to that during your on-call week. Instead, you work on the system. You work on whatever you want. You work on whatever's been bothering you the most, whatever like sticks out like a sore thumb every time, flaky deploys, right? Like broken tests, like whatever just like stands in the way of you being happy operating the system, work on that. When it comes to technical debt, I love the talk right before this. When it comes to technical debt and just like ongoing steady state investment in your systems, you need about 20% steady state just devoted to keeping the wheels on, right? Just paying that debt down a little bit every week. So if you have about 5, 6, 7 people on the team, that's about 20% of your time, right? If the person who's on call is always working on non-feature stuff. It also allows some flex in the schedule so that product isn't overcommitting everyone. Have fun. Also, if you're on call this week, you get next Friday off automatically, always. Everybody deserves a good 3-day weekend after sacrificing a night or two. But, the goodies and the treats, they're fun, they help, But when it comes to work, that's not actually what makes us happy, right? When it comes to work, we all want the same things: autonomy, mastery, and meaning. And if you think about it, seriously, on-call helps with all three. It connects the dots. There is something so viscerally satisfying about fixing production, going from miserable users who are yelling at you to thankful, grateful users. It really, at a gut level, it's so gratifying. A lot of the work that we do as software engineers can be so abstract and can be so far away from the impact of our work. Like, being on call really does help. It helps you feel, it helps with mastery, obviously, because you become such a better engineer if you're taking care of your code and running it as well as writing it. It helps you connect the dots between the work that you're doing, the impact that it has. The one that we typically need to work on more consciously is autonomy, which is why the whole work on whatever you want for a week, and a lot of the stuff around just training and stuff. We need to work on autonomy and not abusing people. But honestly, every place I've ever worked, the ops team has been the team with the most cohesion, the most fun. There's a whole band of brothers type of dynamic that kicks in when you all are doing this very important job, for the company, which presumably you care about and want to succeed. If we don't abuse our people, it doesn't have to be miserable. It really can be pretty fun. Finally, this is my last thing. People are always asked, well, should we pay people for being on call? Some of the arguments are persuasive, some not. I tend to think no. I tend to think it's part of the job, with one big exception, which is that if you're struggling to get people the time they need to fix their systems, fucking pay them. Pay them a lot. Pay them so hard that execs start yelling at you to fix the shit so that you can stop paying your engineers so much. The end.